For this lesson, we want to maximize z equals 2x plus y subject to the constraint equation x squared plus 4y squared equals 4. So what exactly are we trying to do here? Let's visualize it with the geometry first. So I've got the graph here of x squared plus 4y squared equals 4. We want to find which point on this ellipse gives us the biggest value for z equals 2x plus y. If I can't, I like to kind of play a game with a spreadsheet first to get a feel for how it's going to work. So right now, I want to go ahead and program a set of points to see what the highest value is for 2x plus y. But to do that, I'm going to need to solve for y. So how am I going to do that? Well, what can we say? X squared plus 4y squared is 4. So 4y squared is 4 minus x squared. Y squared is 4 minus x squared over 4. Then y is plus or minus square root of 4 minus x squared over 2. So I'm going to jump to my spreadsheet and program it accordingly and see what we get. So I'm going to make this equals 1/2 times the square root of 4 minus x squared, which is 4 minus the x value here, squared. And what is that going to give me? It's going to give me 1. I believe that's correct. We're going to go ahead and autofill this. And then we want to create a table of values for 2x plus y equals 2 times x plus the y value. And we'll see what we get from that. We do an autofill there, and we're looking for the highest value in that column. So let's see what we get. So you'll notice we have 4.1189 seems to be our maximum here. Oh, no, check that. 4.1231049. This seems to be the max. So let's go ahead and share our best guess from looking at the spreadsheet on our page. So there's the information that we have, but now let's go ahead and look again at our geometry to see if that 4.123 answer appears to be a maximum. So we want to find the maximum value for 2x plus y. So we could say 2x plus y equals 1 has those points. 2x plus y equals 2 has those. 2x plus y equals 3 has those points. We think the highest we're going to get is 2x plus y equals 4.123, based on what we saw on the spreadsheet. Does that look pretty good? I'd say that looks pretty good. And might we guess that the minimum would be 2x plus y is negative 4.123? Let's try it. And sure enough, that looks like a pretty good approximation. But these lines are all level curves, and we need to remember that the gradient is orthogonal to the level curves. That will be our key idea here. So let's take a look at what we have here. We have level curves of what form? 2x plus y equals c, our level curves of f of xy equals 2x plus y, and that ellipse that we had, x squared plus 4y squared equals 4, is a level curve of g of xy equals x squared plus 4y squared. So this is what we have, and we need to recognize that the gradient is orthogonal to the level curves. So we need to think visually in terms of what the gradients would be in terms of how we find the point x, y that are going to be the points of tangency. So the key idea is to recognize that the black ellipse is a level curve. The gradient of his generating function is orthogonal. All these lines are also level curves, so their gradient would be orthogonal to the level curve. And at the point of tangency, these gradients are parallel. So the function that defined the red line is f of xy equals 2x plus y. And the function that is going to help us define the black circle, it was a level curve of the function g of xy equals x squared plus 4y squared. So we'll take our gradient, f sub x is 2, f sub y is 1. So the gradient of f is 2 comma 1. Over here, g sub x is 2x. G sub y is 8y. So the gradient of g is 2x comma 8y. Now what we need to do is we need to go ahead and recognize that if they are parallel, then that the gradient of f being parallel to the gradient of g means that the gradient of f is some multiple of the gradient of g, and we have to solve some equations. With this information, we get to 1 is a multiple of 2x comma 8y, which would mean 2 equals 2 lambda x. 1 equals 8 lambda y. And then we have a third equation, which will be the equation of that ellipse, because my point to xy must be on that ellipse. It must satisfy the requirements of the constraint equation. X squared plus 4y squared equals 4. So the way we typically solve this is we solve for lambda. So 2 divided by 2x equals lambda. So 1 divided by x equals lambda. Over here, I need a y, 8 lambda y. That's corrected now. So 1 over 8y equals lambda. So if 1 over x equals lambda and 1 over 8y equals lambda, we equate these two to say 1 over x equals 1 over 8y, which then tells me, of course, that 8y equals x. So replacing 8y with x over here, what am I going to get? 8y is x. 8y squared plus 4y squared is 464. Y squared plus 4y squared is 468. Y squared is 4. Y squared is 4 over 68. So y squared is 1 over 17. So y is plus or minus 1 over the square root of 17. Well, we can see that x is 8 times y. So if y is 1 over root 17, x is 8 times that. X would be 8 over root 17. Similarly, if y is negative 1 over root 17, x would be negative 8 over root 17. So those should be my optimal points. One of them should be a maximum, and one of them should be a minimum. So let's see how it behaves. So let's go ahead and plug those in to see what we get with our x, y, and z. So what I have here is I have what? We have x is 8 over root 17 and y is 1 over root 17. So 2x, 2 times 8 over root 17 would be 16 over root 17, plus 1 over root 17 would give me 17 over root 17 to give me a maximum value of root 17 at that point. Similarly, a minimum value of negative root 17 at that point. So this should be the max, this should be the min. Let's see what those things are as decimal approximations. Our decimal approximations are here, 1.94, 0.243, and 4.123. Notice from our spreadsheet approximations, we said z was 4.123 when x was 1.94 and y was 0.243. That makes me feel awfully good about my spreadsheet approximation. We can also take a look at our graph to show that the 2x plus y equals 4.123 and negative 4.123 indeed were the points of tangency. So the maximum possible value we're ever going to get for 2x plus y will be positive 4.123 here, hitting 1 point there, and negative 4.123 hitting that point there.